my name is Jamie Riley. I'm a professor at Temple University, and I'm here to explain to you and demonstrate how our Semdistflow R package works. So first, what does it do? What it does is it takes any language transcript of any indeterminate size, from one sentence up to Harry Potter and beyond. So for example, the quick brown fox jumps over the lazy dog. What it would do is read that into R, give it a document ID, clean, strip, and vectorize it. So the original sentence, the quick brown fox jumps over the lazy dog, becomes quick brown fox jump over lazy dog. Takes out all the function words, alphanumeric characters. It converts all the words to lowercase. We have a companion paper that explains all of those steps on the Open Science Foundation that I encourage you to read. I'll give you a link to that. And then the final step is that it computes the distance, semantic distance, 2 measures of semantic distance for every sequential pair of words or bigrams in the narrative that you feed it. So quick brown fox jumps over lazy dog becomes quick brown fox, fox jump over lazy, and lazy dog. Each pair of words gets its own semantic distance, or 2 measures of semantic distance. And then that enables you to think of that distance between each pair of words, sequential pair of words across a narrative, as a time series, which is really a different way of looking at language and semantic change over the course of a narrative. Now, how does it work? How would you apply this to your particular language transcripts of interest? Well, the Semdistflow package has 4 primary functions: read text, clean text, dist me, and do it all. Read text is the process of what R does is it takes all the text files, multiple text files, or one text file from within a folder on your computer, and it reads them into R and assigns them a discrete document ID that you can use for summarizing or all sorts of things later. Clean text, then it takes that text and executes a series of regular expressions which strip all alphanumeric characters, converts each word to lowercase, strips out stop words like function words, the and things you don't want, so that you isolate a vector of content words. And then dist me, what dist me does is it takes that long vector of content words and it pairs up each word to its next word and generates pairwise semantic distances for each running pair of bigrams throughout the language transcript that you feed it. It gives you two metrics. One is based on embeddings, word embeddings, and the other is based on experiential semantic ratings, color, sound, and things like that. And then the last function is do it all for people who are really busy and you want to do read text, clean text, and dist me all in one step. Do it all is your one stop for running semantic distance from your text file. So here's how it works in action. You can download a text file, pangram.txt we'll call it, and that is just the quick brown fox jumps over the lazy dog. Here I've saved it on the Open Science Foundation. You can download it or create your own text file. Just call it pangram.txt. What you want to do is download that file, save it somewhere on your computer. Second step, you're going to use the DevTools functions. You'll have to install that DevTools if you don't. And then this is in Markdown, R Markdown. You do install GitHub using calling the DevTools function, and then you install the package from here. It takes a few minutes to install. It has lookup databases, embeddings, stop word lists, all sorts of other things. So give it a minute, and then enable it using the library function. So you're going to library Semdistflow, and that should then make all of the package functions available. So when you do that and you're successful, you'll see a Semdistflow package on your computer next to your other R directories, wherever you tell R to download. And then what you're going to do is you're going to move any of your target text that you want to compute semantic distances on into this folder in the R package folder that you just created when you downloaded the package. So move, in this case, pangram.txt, we're just going to do 1, into my texts. And then once you have that, you're ready to start running. So the first step is read text. So you're going to do the read text function. Here I'm just turning it into a data frame, turning the object into a data frame so I can visualize it for you nicer. Read text creates a unique document ID based on the name of the text file and the directory. And then here's the original document text that you fed into R. So you have this doc text column, and each text file has its own unique identifier. Second step is you are going to clean the text using clean.me. So in that last object that we created, you're cleaning it. You're taking the doc text, and what it's doing is stripping out function words and stripping out punctuation. And you can see here, you then create basically a vector of content words. And then in the last step, dist.me, is you're taking that object, that clean object, and it is then lemmatizing each word, which is basically converting it to its dictionary entry, and then computing a distance between each word and the next. So you have the semantic distance, what are we calling? We're calling semdist 15 semantic dimensions. It's semantic distance in cosine space. And then this is a reverse scored cosine space, which is a scale of 0 to 2, where 0 is no distance between two words, and 2 is the most distant. These are embeddings based on the glove word embedding ratings applied to the COCA lexical corpus. So what you'll get is for every sequential pair of words throughout the narrative, quick brown, brown fox, fox jump, jump over lazy, you will get a semantic distance in experiential space and embedding space. And in the final step, if you don't want to do any of those steps, and you're rushed for time, you can just say do it all, and do it all will take any text file that is in your folder, read it in, clean it, and compute distance and output a tibble, which is all the distances for whatever you feed it. Okay, thanks for watching. If you have any questions, email me, Jamie Riley, at ReillyJ, ReillyJ @temple.edu. Thank you.